Kurt Gödel is the man most logicians will tell you was the greatest of them all, sharper than anyone since Aristotle. In 1978 he died in a Princeton hospital weighing 65 pounds, in a building full of food, because he could not convince himself it was safe to eat. As a boy in Vienna they called him Herr Warem. Mr. Y. He never stopped asking for the reason beneath the reason, and that same relentless mind proved, in 1931, at the age of 25, that no system of logic powerful enough to matter can ever prove itself trustworthy. It cannot rule out its own contradictions. It has to run on a faith it can never justify. He proved that about mathematics. Then, over the last months of his life, he proved it with his body. Tonight we go all the way down, Nigsburg in 1930, the day before the most confident speech in the history of science. The single sentence he built that says of itself that it can never be proven. Turing, and the questions no machine can answer. Einstein, and a birthday gift that quietly suggested time is not real, and a hospital bed, and a wife who tasted his food for 40 years until the day she no longer could. By the end you will understand why the theorem and the death are one story, and why the hole he found in the bottom of mathematics is sitting, right now, in the bottom of you. Get comfortable, and subscribe or join if you have not, because this channel goes all the way into the things other people stop short of. There is a Patreon where these threads run wider, across physics, math, history, and the places they stop being safe. Stay to the end, because the last thing Godel proved is the one that will not let you leave the way you came in. Let's start where it started. On the 14th of January, 1978, one of the most powerful minds in the recorded history of our species died in a hospital bed in Princeton, New Jersey, weighing about the same as a 9-year-old child. 65 pounds. He had not been kidnapped. He was not caught in a famine. He was not, in any medical sense that should have mattered, dying of a disease. There was food in the building. There was a wife 2 miles away who had spent 40 years of her life trying to keep him fed. There were doctors down the corridor whose entire job was to keep people in his condition alive. And he starved anyway. Slowly, deliberately, over a period of months, with full command of one of the sharpest reasoning faculties any human being has ever possessed. He declined to eat until his body gave out. His name was Kurt Gödel, and depending on who you ask, he was either the greatest logician since Aristotle or the greatest logician who has ever lived, full stop, no qualifier. And he ended as roughly 30 kilograms of skin and bone curled into a fetal position because he had become convinced that the food around him was going to kill him, and he could not find, anywhere inside his own head, a way to prove that it would not. Now here is the part I need you to sit with, because it is the reason this is not just a sad story about a genius who lost his mind. The thing this man is most famous for, the single discovery that put his name in every serious book ever written about the limits of human knowledge, is a mathematical proof. And that proof, stripped down to one sentence, says that no system of reasoning powerful enough to be interesting can ever fully check itself from the inside. It cannot prove that it is trustworthy. It cannot guarantee that it will never contradict itself. There will always be true things it cannot reach, and there will always be a question about its own reliability that it is structurally forbidden from answering. Not because we are not clever enough yet, not because we need better computers, but because the answer is walled off by the same logic that makes the system work at all. He proved that in 1931, when he was 25 years old, and then, 47 years later, he demonstrated it with his body, in a hospital bed, unable to step outside his own reasoning long enough to see that he was safe. I have spent an unreasonable amount of time reading about this man, and I still do not entirely know how to hold those two facts in the same hand. The theorem and the death are not two separate events that happen to involve the same person. They are the same shape. They rhyme. And once you see the way they rhyme, you cannot unsee it, and it starts to say something about you that I am not sure you are going to enjoy hearing. Because the question underneath all of this, the one that stays open from here to the end, and that I do not think anyone has ever really closed, is whether any system that can reason about itself can ever actually trust itself. Whether mathematics can, whether a mind can, whether you can. And the man who got closest to the answer is the one who starved to death rather than eat a spoonful of food his wife had not personally tasted first. Let me tell you what you were not told about how mathematics actually works, and then let me tell you what it did to the man who found out. The version most people carry around is that mathematics is the one place where things are certain. Everything else in life is opinion and probability and vibes, but 2 plus 2 is 4, and it was 4 before there were humans, and it will be 4 after we are gone, and if you build carefully enough on top of facts like that, you can reach absolute, unshakable, permanent truth. That is the promise. That is why we teach children arithmetic as if it were the floor of reality, the thing you stand on when everything else is shifting. Mathematics is where we keep our certainty. And for a stretch of about 30 years, at the turn of the 20th century, the smartest people alive believed they were about to make that promise literally true, not poetically true. Provably, mechanically, permanently true. They believed they were on the verge of building a foundation for all of mathematics so secure that every mathematical question, every one that had ever been asked, and every one that ever could be, would be answerable, and that the whole structure could be proven from the inside to be free of any contradiction forever. They thought they were about to lock the vault and throw away the possibility that anything could ever get in. The man leading that effort was named David Hilbert, and to understand how big this crash is going to be, you have to understand that Hilbert was not a crank on the fringe. He was the most influential mathematician in the world. He worked at Göttingen in Germany, which at that time was the centre of the mathematical universe the way that certain cities are the centre of art or money or power. If you wanted to do serious mathematics in the early 1900s, you went to Göttingen and you tried to get near Hilbert, and the phrase people used, the one carved into the culture of the place, was that there was mathematics, and then there was the mathematics they did at Göttingen. In 1900, at a conference in Paris, Hilbert had stood up and laid out a list of 23 unsolved problems that he thought should guide the next century of mathematics, and mathematicians spent the next 100 years working through that list, and many of them built entire careers on solving a single item. The second problem on that list was to prove that the axioms of arithmetic can never lead to a contradiction. To prove, in other words, that the foundation was solid. He put it second. Second out of 23. That is how fundamental he thought it was. By the late 1920s, Hilbert had turned this into a full program, a specific plan with a specific goal, and the goal had 3 parts, and I want to name them clearly because the entire tragedy hinges on watching them fall. First, mathematics had to be complete, meaning every true statement could be proven within the system. If it was true, you could get to it. Nothing true would be forever out of reach. Second, mathematics had to be consistent, meaning it would never prove 2 things that contradicted each other, never prove a statement, and also prove its opposite. Because a system that can prove a contradiction can be manipulated to prove literally anything, and is therefore worthless. And third, mathematics had to be decidable, meaning there existed a definite procedure, a mechanical method. That could take any mathematical statement and determine whether it was true or false. Complete, consistent, decidable, get all three, and you have done it. You have built the machine that answers every question and never lies and can be trusted absolutely, forever, and you have proven from the inside that it can be trusted. That was the dream. And it was not a childish dream. It was the considered goal of the finest mathematical minds on the planet, and they were closing in on it. In September of 1930, in the city of Nigsburg, which was Hilbert's birthplace, there was a large meeting of German scientists, and Hilbert was retiring, and he gave a farewell address that has become one of the most famous speeches in the history of science, partly for its confidence and partly for the timing, which you are about to understand is almost unbearable. He was pushing back against an old idea, a resigned idea, that there are things human beings simply will never know, questions that are permanently closed to us. There was a Latin phrase for that resignation, ignoramus et ignorabimus, which means we do not know and we will not know. And Hilbert stood up in Nigsburg and rejected it completely, and he ended his address with a line that they later engraved on his tombstone. Wir müssen wissen. Wir werden wissen. We must know. We will know. There is even a recording of the last minute of it, his voice, insisting that there are no unsolvable problems, that the boundary de Bois-Reymond had drawn around human knowledge was an illusion, that everything could be known. He gave that speech on the 8th of September, 1930. And here is the timing I told you was almost unbearable. The day before, on the 7th of September, in the very same city, at a smaller academic session attached to the same gathering, a 24-year-old with almost no reputation had sat in a discussion and mentioned, quietly, almost as an aside, that he could construct true mathematical statements that could not be proven. That completeness was impossible. That Hilbert's first pillar was already, at that moment, in the discussion room next door, a corpse. Almost nobody in the room understood what they had just heard. The young man was Kurt Gödel, and he had, the day before the most confident speech in the history of mathematics, already killed the thing the speech was about. Only one person present grasped it immediately. That was John von Neumann, who was himself one of the towering intellects of the century, and von Neumann understood the moment fast enough that he went home, worked out a consequence Gödel had implied, and wrote to him about it. And Gödel wrote back, essentially, "Thank you, I already have that. It is in the paper." Von Neumann was so shaken by the result that he later said he stopped working on the foundations of logic altogether, and he told his classes for years afterward that everything he had believed about the certainty of mathematics had been wrong. This is a man who went on to help build the atomic bomb and invent the architecture of the computer you are holding, and the thing that stopped him cold, the thing that made him step back from an entire field, was a proof written by a sickly 25-year-old from Vienna. But I am getting ahead of the human being, because before Gödel was the man who ended the dream, he was a boy in a textile town, and the shape of what would eventually kill him was already visible when he was 6. He was born on the 28th of April, 1906, in Bryn, which was then part of the Austro-Hungarian Empire, and is now the city of Brno in the Czech Republic. His family was comfortable, his father managed a textile factory, and Kurt was a strange, precise, relentless child, so relentless with his questions that his family gave him a nickname that is going to sound like something a screenwriter invented, except it is documented and real. They called him Herr Warham, Mr. Y. He wanted the reason for everything, the reason under the reason, the axiom beneath the axiom, and he did not stop. When he was around 6 years old, he had rheumatic fever. He recovered completely. There was no lasting damage. But at the age of 8, he read a medical book about the illness, and somewhere in that book he found a description of how rheumatic fever can permanently weaken the heart, and the 8-year-old Kurt Gödel decided that this had happened to him. That his heart was damaged, that it would always be damaged. There was no medical evidence for this. Every doctor who ever examined him found a functioning heart. But he believed it for the rest of his life, and he organized his behavior around it, and I want you to notice what actually happened there, because it is the first appearance of the exact mechanism that will end him 70 years later. A child took a true general fact, that rheumatic fever can damage hearts, applied flawless local logic, I had rheumatic fever, therefore my heart may be damaged, and arrived at a conclusion that was false and that no amount of external evidence could ever dislodge, because the conclusion had been reached from the inside, and the inside was where he lived. The reasoning was not broken. That is the horror of it. The reasoning worked perfectly. It just could not get outside itself to check the result against the world. Hold on to that, because we are going to watch it happen again at a much larger scale, and then we are going to watch it happen a third time to mathematics itself. He went to Vienna to study, and he arrived at exactly the right moment to fall in with exactly the right group of people to sharpen him into a weapon aimed at the foundations of certainty. The group was the Vienna Circle, a collection of philosophers and scientists who met to discuss logic and language and the structure of knowledge, and they were led by a physicist and philosopher named Moritz Schlick. Remember that name. Godel attended their meetings. He was quiet, he mostly listened, and he disagreed with almost all of them on a point so fundamental that it explains everything he later did. The Vienna Circle mostly believed that mathematics was, in the end, a human invention, a set of rules we made up, elaborate bookkeeping, true only in the sense that a game of chess has rules. Godel thought that was not just wrong, but obviously wrong. He believed that mathematical objects were real, that numbers exist, that when a mathematician proves a theorem, they are not inventing anything, they are discovering something that was already true, out there, in a realm as real as this table, and that they are perceiving it with a faculty as legitimate as sight. This position is called mathematical Platonism, and Gödel held it more seriously and more literally than almost anyone of his era, and it matters enormously for where this story goes. Because a man who believes mathematical truth is a real place he can see is a man who is going to be uniquely tormented when he proves that parts of that place can never be reached. He finished his doctoral dissertation in 1929, and that dissertation, before he became famous for limits, actually proved something positive. He proved that a certain basic system of logic was complete, that everything true in it could be proven. He gave Hilbert a small victory, and then, almost immediately, he turned the same ferocious machinery on the larger system. On arithmetic itself, the thing Hilbert actually cared about, and he found the crack. Which brings us to the paper. The paper was published in 1931 in a German mathematics journal, and its title, translated, is On Formally Undecidable Propositions of Principia Mathematica and Related Systems. Principia Mathematica was the enormous 3-volume work by Bertrand Russell and Alfred North Whitehead that had tried to derive all of mathematics from pure logic, one of the grandest attempts at the foundation ever made. A book so rigorous, it takes hundreds of pages to prove that 1 + 1 = 2. And Gödel's title is telling you right there, in the politest possible academic language, that he is about to demonstrate that this monument, and everything like it, contains statements that can never be settled. Undecidable propositions, not hard propositions, not unsolved propositions, propositions that the system itself renders permanently unreachable. I am going to walk you through what he actually did, slowly, because this is the intellectual core of everything, and because the popular summaries of it are so vague that they rob it of its menace. This is not going to require you to know any mathematics. It is going to require you to follow one genuinely strange idea, and if you follow it, you will understand something that most people who confidently reference this theorem have never actually understood. Start with the oldest trap in language, a sentence that eats itself. This sentence is false. Say it out loud. If it is true, then what it says is the case, and what it says is that it is false, so it is false. But if it is false, then what it says is not the case, and what it says is that it is false, so it is not false, so it is true. It flips forever. It cannot be true and it cannot be false. This is the liar paradox, and it is thousands of years old, and for most of those thousands of years, it was treated as a curiosity, a bit of wordplay. The kind of thing you show a clever teenager. Gödel looked at it and saw a weapon, and the genius, the specific move that changed the history of thought, was figuring out how to smuggle a version of that self-devouring sentence into the middle of arithmetic, where it could not be dismissed as mere wordplay, because arithmetic was supposed to be the safe place, the place where sentences behave. Here is the problem he had to solve to do it. Arithmetic talks about numbers. It says things like there are infinitely many primes, or every even number is the sum of two odds. It does not, on its face, talk about sentences, or proofs, or itself. So how do you get a statement about numbers to secretly be a statement about statements? How do you make arithmetic self-aware? What Gödel did is one of the most beautiful ideas I have ever encountered, and it is called Gödel numbering. He set up a code. Every symbol in the mathematical language got assigned a number. Then every formula, which is just a string of symbols, got assigned its own single number, built out of the numbers of its symbols in a specific, reversible way, using prime numbers so that the coding could never be ambiguous. And then, crucially, every proof, which is just a sequence of formulas, also got its own single number. So now every statement in the entire system, and every proof in the entire system, has a unique numerical fingerprint. A statement is a number. A proof is a number. And here is the hinge on which the 20th century turns. Once statements and proofs are numbers, then statements about statements and statements about proofs become statements about numbers. Which means arithmetic, which was only ever supposed to talk about numbers, can now talk about itself. It can encode sentences like this formula is provable, or this formula is not provable, because provability has become a relationship between numbers. An arithmetical property, something the system can express in its own native language. Sit with that for a second, because it is genuinely one of the strangest true things about reality. Numbers can describe the rules that govern numbers. The system can build a mirror inside itself out of its own material. There is no outside step, no cheating, no bringing in a human observer. Arithmetic, left alone, contains the capacity to describe arithmetic. And once you can do that, Godel builds the sentence. He constructs, using nothing but the legal machinery of the system, a specific mathematical statement whose meaning, when you decode it, is this. This statement cannot be proven within this system. Let me call it G. G is a real, legitimate arithmetical statement, a claim about numbers, sitting inside the system exactly like any other. And what it says about itself, once decoded, is that no proof of it exists in the system. Now watch what happens, because this is the whole thing, this is the trap closing. Ask the simple question: is G provable in the system? Suppose it is. Suppose there is a proof of G inside the system, but G says of itself that it has no proof inside the system. So if you have proven G, you have proven a false statement, because G claimed to be unprovable and you just proved it. A system that can prove false statements is inconsistent. It is broken. It is the thing Hilbert feared most. The system that proves contradictions, and therefore proves everything and means nothing. So if we are going to assume the system is sound, that it does not prove falsehoods, then G cannot be provable. But now look at where that leaves us. We have just reasoned our way to the conclusion that G cannot be proven in the system, and that is exactly, word for word, what G says about itself. G says, I cannot be proven here. And we just showed that G cannot be proven there, which means G is true. It is a true statement. We can see that it is true. We just did, standing a little outside the system, following the logic. And it is a true statement that the system itself can never, ever prove. That is the first incompleteness theorem. Any consistent formal system rich enough to contain basic arithmetic contains true statements that it cannot prove. Truth outruns proof. Forever, not because the statements are exotic, but because you can always build one mechanically for any such system, no matter how many axioms you add. Add a new axiom to capture G, make G provable, and the very same construction hands you a new sentence. G2, true and unprovable in the enlarged system. Add that one, and here comes G3. There is no finishing. There is no version of mathematics rich enough to be useful that is also complete. The completeness pillar, the first of Hilbert's three, the one he had put at the centre of his life's ambition, was gone. And the man who removed it did it the day before Hilbert stood up in Nigsburg and swore that we would know everything. I want to stop here and correct something, because we are past the point where the casual audience has drifted off, and I am talking to the people who actually want this to be right, and this result is probably the most misused theorem in the history of ideas. You have almost certainly heard it invoked to mean something it does not mean. You have heard people say Gödel proved that nothing can be truly known. You have heard that he proved mathematics is broken, or inconsistent, or self-contradictory. You have heard it dragged into arguments about God, about the impossibility of certainty in general, about postmodern claims that all truth is relative, that there is no such thing as objective fact, and that even the mathematicians admit it. Every one of those uses is wrong, and Godel, who believed in objective truth more fiercely than almost anyone, would have found them not just mistaken, but backwards. The theorem does not say nothing can be known. Look at what we just did. We knew G was true. We were more certain of G than of almost anything. The theorem is not about the limits of knowledge, it is about the gap between what is true and what can be proven inside one particular formal system. Truth did not shrink. Proof did. In fact, the theorem shows that truth is larger than proof, that there is more that is true than any single mechanical system can ever capture, which if anything is a statement about the abundance of truth, not its absence, and it does not say mathematics is inconsistent. The exact opposite. The theorem assumes the system is consistent and derives incompleteness as the price of that consistency. It is a theorem, a proven result, a piece of rock-solid mathematics about the limits of rock-solid mathematics. There is a Swedish logician named Torkel Franzen who wrote an entire careful book just to clean up the wreckage of people misusing this result in theology and philosophy and pop culture, and his basic point, which I agree with completely, is that the theorem is precise and narrow and devastating exactly, because it is precise and narrow, and that smearing it into a vague slogan about how nothing is certain destroys the one thing that makes it terrifying, which is that it is certain. It is not a permission slip for relativism, it is a proof, and the people who wave it around to argue that truth is whatever you want it to be are standing on a theorem that proves truth is real and specific and in this one structural way, forever beyond total capture. So no, this is not the story of mathematics falling apart. It is worse than that. Mathematics did not fall apart. It kept working perfectly. It just proved, about itself, with total rigour, that it can never fully vouch for itself, And that distinction, the difference between a thing that breaks and a thing that works flawlessly while proving it can never fully trust itself, is going to be the difference between a sad man who went crazy and the actual much darker story of what happened to Gödel. Because the first theorem, the one about true statements you cannot prove, is the famous one, but it is not the one that should keep you up tonight. There was a second theorem in that same 1931 paper, and it is the one that reaches out of the mathematics and puts its hand around the throat of everything, including you, and I need to show it to you before we go any further into the life of the man it destroyed. The second incompleteness theorem follows from the first, and it is short to state and almost impossible to sit with calmly once you understand it. Take a system, the same kind as before, consistent, rich enough for arithmetic. We establish that it contains true things it cannot prove. Now ask a different question. Can the system prove its own consistency? Can it prove, about itself, using its own rules, the single most important fact it would ever want to establish, which is that it will never contradict itself, that it will never prove a falsehood, that it can be trusted? That is the thing Hilbert wanted above all. Not just that the system works, but that the system can certify, from inside, that it works. Godel proved it cannot. He showed that if such a system could prove its own consistency, then it could also prove the very sentence G that we already established it cannot prove, and the whole thing collapses into contradiction. So a consistent system cannot prove its own consistency. The only systems that can prove they will never contradict themselves are the ones that already do contradict themselves, the broken ones. The ones whose word is worthless precisely because a broken system can prove anything, including its own reliability. A trustworthy system cannot demonstrate that it is trustworthy, and a system that loudly demonstrates its own trustworthiness has, by that very act, revealed that it is not. Read that again slowly, because this is the sentence the whole story has been walking toward. The only mind that can prove it is sane is a mind that is not. That is not a metaphor I am imposing on the mathematics. That is the mathematics, stated in its own terms, and then followed one step further into the room where a human being actually has to live. Any system powerful enough to reason about itself is forbidden, by the structure of reason itself, from certifying its own soundness. It has to trust itself without proof. It has to take, as an article of faith, the one thing it most needs to know and can never establish. Mathematics, the place we invented to escape faith, turns out to run on faith at the deepest level. You cannot get underneath it. There is no floor under the floor. You reach the bottom of certainty and find that the bottom is holding itself up by assumption, and there is no way from inside to check. Hilbert's second pillar, consistency, provable consistency, was now gone too. Two of the three pillars destroyed in a single paper by a single man in his mid-20s. The third, decidability, the dream of a mechanical procedure that could answer any mathematical question, would fall a few years later to a young Englishman named Alan Turing. And we will get there, because the way it fell built the machine you are watching this on, and that is one of the darker jokes in this entire story. But first I want to bring the man back, because something happened to Gödel in the years right after he proved all this, and it is the first time the pattern in his life becomes impossible to look away from. You would think that proving one of the deepest results in the history of human thought would be a triumph, that it would open every door, that the world would carry him around on its shoulders. It did not. For years, much of the mathematical establishment did not even seem to fully register what he had done. The result was too strange, too much against the grain of what everyone wanted to be true. And there is a pattern here that recurs across the whole history of uncomfortable ideas, where a discovery that should be front-page news gets filed under technical curiosity because the alternative actually absorbing it, is too disturbing to the people whose careers are built on the opposite assumption. Hilbert himself, when he finally learned of the result, is reported to have reacted with anger before he came around. His life's program had been gutted, and the human response to having your life's program gutted is not usually gratitude. I want to slow down on the reception, because the way a discovery this large gets absorbed tells you something about how knowledge actually moves, and it is not the clean story where genius is recognized and the truth wins. When Gödel spoke that first announcement at Nigsberg in September of 1930, the discussion moved on almost immediately to other things, as if a man had not just told a room full of the leading logical thinkers in the world that their central goal was impossible. The published record of that session shows the conversation continuing past him. Von Neumann was the exception, the one mind fast enough to feel the floor go, and even von Neumann had to go home and work for weeks before he fully grasped the size of it. For a stretch after the paper appeared in 1931, some serious mathematicians simply did not believe it, or believed it must contain an error, or believed it was a narrow technical result about the particular system Russell and Whitehead had built, rather than a universal limit on all such systems. Ernst Zermelo, one of the founders of modern set theory, corresponded with Gödel and got the result wrong, misunderstood the construction, thought he had found a flaw when he had only found his own confusion. This is not a story where the world gasped and bowed. This is a story where one of the deepest truths ever proven landed in a room, and the room mostly kept talking, and it took years for the field to even agree on what had happened. And notice the shape of the excuses, because it is a pattern that repeats every time an uncomfortable result arrives. First, the result is doubted. It must be wrong. Then, when it survives scrutiny, it is minimized, it is only about this one artificial system, it does not touch real mathematics. Then, when that fails too, it is quarantined. Yes, it is universal, but it only affects strange self-referential statements no working mathematician cares about. Doubt it, then shrink it, then wall it off. 3 moves, and all 3 are ways of not absorbing the thing, of keeping the comfortable picture intact by declaring the discovery smaller than it is. The one thing the establishment never quite did was the thing the result actually demanded, which was to stand up and say plainly that the dream of a complete self-justifying mathematics was over, permanently, for everyone, forever, and to teach that to every student as the first and most important fact about the foundations of the subject. That announcement was never really made. It is still, in a sense, not made. The result won on paper and lost in the culture, and it lost not by being refuted, but by being filed, and the filing is the scandal, and the filing is why you reached adulthood believing mathematics is where certainty lives. And Godel, who was never sturdy to begin with, began to come apart. In the mid-1930s, he suffered a series of breakdowns. He was hospitalized for depression, for nervous exhaustion, and he spent time in sanatoria, the institutions of the era for people whose minds were failing in ways nobody could quite name. He became convinced, more and more, that he was physically ill, cycling through ailments that doctors could not find. The hypochondria that had started with an 8-year-old and a medical book was metastasizing into something that touched everything, but the event that seems to have broken something in him permanently happened on the 22nd of June 1936 on the steps of the University of Vienna. Moritz Schlick, the leader of the Vienna Circle, the intellectual centre of Godel's world, was walking up the staircase of the university to give a lecture when a former student named Johann Nelp pulled out a pistol and shot him dead. The motives were a tangle of personal grievance and delusion and the poisonous politics of Vienna in 1936, a city sliding toward the Nazi takeover that would come 2 years later, and the aftermath was almost worse than the murder. Because the killer was celebrated in some quarters, his defense wrapped itself in anti-Semitism even though Schlick was not Jewish, and he ended up serving very little time before being released. A brilliant man was murdered on a public staircase by someone who should have been nowhere near him, and the institutions that should have delivered justice instead half excused it. And Kurt Gödel, who had sat in that man's seminars, who had built his early life around that circle, responded to the killing with a nervous crisis so severe that he spent months in an institution, and from this point forward the fear that his food might be poisoned, which had flickered before, became a fixed and permanent feature of how he lived. Think about the specific shape of that fear in the specific mind that now held it. Here is a man who has just proven, more rigorously than anyone in history, that a system of reasoning cannot step outside itself to verify its own soundness, that there is always a gap between what is true and what you can confirm from the inside. And here is that same man, now unable to confirm, from inside his own reasoning, whether the food in front of him is safe. He cannot prove it is poisoned. But he cannot prove it is not. And the not is the one that matters, the one his whole survival depends on, and it is exactly the kind of statement his own theorem told him he might never be able to reach. I am not saying he consciously applied his theorem to his lunch. I am saying the same structural trap, the inability of a system to get outside itself and check, was operating in the mathematics and in the man at the same time, and that the man had spent his genius mapping the exact shape of the cage he was now living inside. I told you at the start that the theorem and the death are the same shape. This is where you begin to feel it rather than just be told it. And it is going to get worse, because the fear did not stay in the kitchen. It spread into how he trusted other people, how he trusted institutions, how he trusted the very ground of what was real, and the only thing standing between Kurt Gödel and starvation. For the next 40 years was going to be one woman, and the day she could not stand there anymore is the day the story ends. But before we get to her, I have to finish telling you what happened to his idea, because the way the world handled the most important logical discovery of the century is its own quiet scandal, and it tells you something about how uncomfortable truths get managed. Von Neumann, as I said, walked away from foundations entirely. One of the greatest problem solvers who ever lived looked at what Gödel had done and decided the ground he had been standing on was gone, and he redirected that colossal mind toward game theory, toward quantum mechanics, toward the bomb, toward computers, toward almost anything other than the question of whether mathematics could justify itself, because Gödel had shown that it could not, and there was nothing left to do there. When people describe von Neumann's range, the sheer number of fields he transformed, they rarely mention that part of what powered that restlessness was a foundational despair, a sense that the bottom had dropped out, and that he was building on the upper floors precisely because the basement had been condemned. And here is a correction I have to make, because it is one of the most repeated false facts about Godel, and this audience deserves the real version. You will very often hear that it was Einstein who called Godel the greatest logician since Aristotle. It is a lovely line, and it appears all over the internet attached to Einstein's name. It was not Einstein. The description of Godel as the greatest logician since Aristotle traces to von Neumann, the man who understood the work most immediately and most personally, and it carries more weight coming from him than it would from Einstein, because von Neumann was himself a logician of the first rank and knew exactly what he was measuring. Later the physicist John Wheeler said that if you called Gödel the greatest logician since Aristotle, you were actually selling him short. The people best equipped to judge did not think this was hyperbole. They thought the hyperbole did not go far enough, and yet if you ask most educated people what Kurt Gödel did, you will get a blank or a vague gesture at something about math being incomplete. Filed next to the Heisenberg uncertainty principle, in the drawer of things smart people are supposed to nod at without understanding. The most important limiting result in the history of human reason and it lives in that drawer. That is the invisible scandal, and it deepens because the discomfort was not passive. Ideas this disruptive get metabolized by intellectual culture in a specific way, and the way is to either ignore them or to declaw them, to turn them into a slogan so blurry it stops threatening anyone. Incompleteness became a party trick. It became the thing you cite to sound deep. It got absorbed into postmodern theory to argue that all knowledge is unstable, which is close to the reverse of what it says. It got pulled into arguments about the divine and arguments about the meaninglessness of everything by people who had never followed the actual construction and did not know that the sentence G is provably true, that the whole force of the thing is that truth survives, and it is only proof that fails. The theorem that most precisely defends the reality of objective truth got conscripted into the war against it, and almost nobody noticed, because almost nobody had read the paper, because the paper is hard, and because the version in the drawer was so much more convenient. Now, the third pillar. Decidability. The dream that there could be a mechanical procedure, a definite step-by-step method, that would take any mathematical statement and grind out a yes or a no. Gödel's theorems had not directly killed this one. It took a different mind, and the way that mind killed it created the modern world, which is the kind of irony this story keeps producing whether you want it to or not. In 1936, a 23-year-old at Cambridge named Alan Turing was trying to answer Hilbert's decision problem, and to do it, he had to first pin down what a mechanical procedure even is. What does it actually mean to follow a definite method, to compute, to calculate, in a way that requires no insight, no creativity, just rule following? And to make that precise, Turing imagined a machine. A very simple, abstract machine, a strip of tape divided into squares, a head that can read and write symbols on the tape, and move left or right according to a table of rules. That imaginary device, the Turing machine, is the mathematical definition of computation, and it is the direct ancestor of every computer that has ever been built. The phone in your hand, the servers streaming this to you, all of it is a physical approximation of the abstract machine Turing invented to answer a question about the limits of mathematics. And the answer he found was no. There is no such general procedure. Turing proved it by asking whether there could be a method that determines, for any program and any input, whether that program will eventually halt or run forever. This is called the halting problem, and Turing showed it is undecidable. No machine, no method, no algorithm can answer it in general. And his proof runs on exactly the same fuel as Godel's: self-reference and diagonalization, the same move of turning a system's own machinery back on itself until it chokes. If you had a program that could always tell whether any program halts, you could use it to build a program that halts if and only if it does not halt, and the contradiction destroys the assumption. It is the liar paradox again, wearing the clothes of a machine. The third pillar fell the same way as the first two, cut down by the system's own reflection of itself. So there it is, the full wreckage. Complete, gone by Gödel. Consistent and self-certifying, gone by Gödel. Decidable, gone by Turing. The entire program to make mathematics into a closed, complete, self-justifying fortress of certainty was over inside of a decade, and every single blow landed by the same mechanism. A system turning to look at itself and discovering that the act of looking opens a hole that cannot be closed, and the discovery that ended it, in Turing's hands, became the blueprint for the machine that now runs civilization. We built the modern world out of a proof about the limits of the modern world's central dream, and that undecidability is not locked away in the theory either, the way people want to believe the incompleteness is locked away in weird self-referential sentences. It leaks into the machines on your desk, right now, in ways you rely on without knowing it. A few decades after Turing, a logician named Henry Rice proved something that generalizes the halting problem into a sweeping statement about software, and the rough content of it is that essentially any interesting question about what a program will do, in general, for all programs, is undecidable. There is no algorithm that can look at arbitrary code and tell you for certain whether it contains a particular kind of behavior. Which means, concretely, that a perfect virus scanner is mathematically impossible. Not difficult, not expensive. Impossible in the same way squaring the circle is impossible, proven, closed. You cannot write a program that correctly detects. For every possible program, whether that program is malicious, because detecting the behavior in general is undecidable, and this is why your antivirus software works by guessing, by pattern matching known threats, by heuristics that are wrong often enough that new malware gets through constantly. It is not that the security industry has not tried hard enough. It is that Turing closed the door in 1936, and the door stays closed. The same theorem tells you that no program can, in general, verify that another arbitrary program is bug-free, which is why software has bugs forever, why the most careful formal verification can only cover narrow, carefully bounded cases, why the dream of a machine that checks all our other machines and certifies them sound is exactly as dead as Hilbert's dream, and for exactly the same reason. The machine cannot fully verify the machine. The system cannot certify the system. Every time an update fails, every time a program hangs and you force it to quit, you are brushing up against a hole that Gödel and Turing proved can never be filled. The cage is not a philosophy seminar. It is in your pocket, and it is why the thing in your pocket can never be made perfectly safe. But mathematics is abstract, and machines are out there, on the desk, other. The moment this stops being a story about symbols and starts being a story about you is the moment someone asks the obvious next question, the one Godel himself could not stop asking, and it is this. If no formal system can escape these limits, and if the human mind is a kind of system, then are you in the cage too? Is your own reasoning subject to the same trap door? Can you trust yourself? And that question does not have a comfortable answer, and Gödel's own attempt to answer it is one of the strangest things he ever did. Godel thought about the mind and machine question directly, and he said something about it that almost nobody quotes correctly, because the correct version is more careful and therefore less exciting than the version that got popular. In 1951, he gave a prestigious lecture to the American Mathematical Society, and in it he laid out what he thought his own theorems implied about the human mind, and he was too rigorous to overclaim. He did not say his theorems prove the mind is more than a machine. He said something stranger and more honest. He said the theorems force a choice between two options, and that at least one of them must be true. Either the human mind is not equivalent to any finite machine, meaning there is something we can do that no mechanical system can capture, or there exist mathematical problems that are absolutely unsolvable. True statements that not just this or that system, but no possible mind and no possible machine could ever settle. One or the other. Possibly both. He personally leaned toward the first, toward the mind exceeding the machine, and toward there being no absolutely unsolvable problems, because his Platonism made him an optimist about what the mind could ultimately reach. But he was careful to say he had not proven it. He had proven the fork in the road. He had not proven which branch we are on. Now here is the misconception, and it is a big one, because two well-known thinkers took Gödel's careful fork and turned it into a blunt slogan. A philosopher named John Lucas, and later the physicist Roger Penrose, argued that the incompleteness theorems flat out prove that the human mind is not a computer, that we can see the truth of the Gödel sentence which no formal system can prove, Therefore we are doing something no machine can do, therefore consciousness transcends computation. It is a seductive argument. It has launched 1,000 late-night conversations. And most logicians think it is wrong, and I think it is wrong, because it quietly assumes the thing it needs to prove. To see that the Gödel sentence of a system is true, you have to assume that system is consistent, and by Gödel's own second theorem, you cannot in general prove the consistency of a system as rich as your own mind from the inside. You would have to step outside yourself to verify your own soundness, and that is exactly the move the theorem says you cannot make. So the Lucas and Penrose argument, in trying to prove the mind escapes the cage, smuggles in the assumption that the mind can do the one thing the cage forbids. It is not a proof that you are free, it is a proof that you want to be. And Gödel's actual position, the careful fork, is so much worse, because it does not let you off the hook. It says that either your mind is doing something genuinely beyond any mechanical account, which we cannot demonstrate and may never be able to, or there are truths permanently sealed off from every possible knower, forever, which is its own kind of horror. There is no comfortable branch. Both roads lead somewhere you do not want to end up. The mind either exceeds all systems in a way we can never confirm, or it is trapped, like every system, with a locked room at its center. That is the real inheritance. Not the reassuring slogan that you are more than a machine, the unfalsifiable dread that you might be, or the equal dread that some truths will die with the universe unproven, and that you have no way, from where you are standing, of knowing which. I want to pull back from the edge of that for a moment, because you need to breathe, and because the human being at the center of this had, against every probability, a few years of something like happiness, and it happened in a small university town in New Jersey, walking beside the most famous scientist on Earth. Godel got out of Europe in 1940, and the way he got out is its own small epic. By then Austria had been absorbed into Nazi Germany, his position in Vienna had been eliminated, the German army had found him fit for military service, and staying meant almost certain catastrophe for a man of his fragility, with his connections to a circle the regime despised. So Godel and his wife did not flee west across the Atlantic, which was the obvious route. They fled east. They took the Trans-Siberian Railway all the way across the Soviet Union to the Pacific coast, then a ship to Japan, then another ship across the Pacific to San Francisco, arriving in early 1940, then a train across the entire United States to Princeton. They circled most of the way around the planet to reach a town they could have crossed an ocean to get to, because the ocean route was closed by war. And waiting for him in Princeton was a position at the Institute for Advanced Study, the same institution that housed Albert Einstein. I have to tell you about the wife now, because I have been holding her at the edge of this story, and she is the load-bearing wall of the whole thing. Her name was Adele Nimbursky, born Paulkert. She was a dancer, she had been married before, she was 6 years older than Godel, she came from a working-class Viennese background, and by every account, she was warm, earthy, protective, fierce, and absolutely nothing like the ethereal abstract man she married in 1938 over the loud objections of his family, who thought she was beneath them. She was, in the most literal sense, the thing that kept him alive. She managed his fears, she ran interference with the world, and, at the center of it, she handled his food. Because Godel's terror of being poisoned meant that for decades, he would essentially only eat what Adele prepared and, in the accounts that survive, what Adele had effectively tasted first, so that his trust in the safety of a meal was outsourced to her body, to the fact that she had eaten it and was fine. He could not verify the food was safe from inside his own reasoning, so he borrowed hers. She was the outside view he could not generate himself. Remember that. She was his consistency proof, the external check his own mind was forbidden to perform, and she was made of flesh, and flesh does not last. In Princeton, though, in those years, there was Einstein, and the friendship between them is one of the genuinely touching things in this whole grim account. They were an odd pair. Einstein was warm, rumpled, sociable, a public figure who had become a kind of secular saint. Godel was thin, formal, precise, terrified of drafts and refrigerator gases and the intentions of strangers, wrapped in heavy overcoats even in the New Jersey summer. And they walked together nearly every day, to and from the Institute, talking in German. And the other members of the Institute could only watch and wonder what on earth these two were saying to each other. Einstein was 27 years older, at the height of his fame and near the end of his life, and he said something about this friendship that tells you how much it meant to him. He told the economist Oscar Morgenstern, who was close to both men, that his own work no longer meant much to him, and that he came to the Institute mainly to have the privilege of walking home with Gödel, the most famous scientist on the planet, saying that the best part of his day was the walk beside the strange, frightened logician who thought his heart was broken and his food was poison. There was something in that mind that Einstein could not get anywhere else, and he arranged his days around it. And you have to hold that friendship against the backdrop of how the rest of the Institute treated Gödel, because it sharpens what Einstein was doing. Gödel had come to the Institute for Advanced Study, which was built specifically to be a place where great minds could think without the burdens of teaching or administration, a kind of monastery for the intellect. And for years, this institution, which existed for exactly the purpose of housing someone like him, would not give him a permanent professorship. He was kept on temporary appointments, year to year, an ordinary member rather than a professor, and part of the reason was a fear among some of the faculty that his fragility, his fears, his difficulty made him a risk. There were people at the Institute who worried that if they made him a full professor, he might in some meeting use his relentless logic to argue for something bizarre, or that his mental state made him unsuitable for the responsibilities. So the man now regarded as the greatest logician since Aristotle sat in the world's premier institute for advanced thought on a temporary contract for years. Partly because his colleagues were nervous about him, he was not made a full professor until 1953, more than a decade after he arrived. And even then it happened partly because Einstein and a few others pushed for it. Einstein was not just walking beside a friend, he was, in a quiet way, protecting a man the institution around them found difficult, vouching for him, the way Adele vouched for the food, being an external source of legitimacy for someone who could not always generate his own standing in the world. Adele was in Princeton too, of course, and the marriage in exile was its own strange and tender arrangement. She never fully fit into the rarefied academic world he inhabited, the world of Einstein and von Neumann and the Institute's refined social life. She was a former dancer with a Viennese working-class accent, warm and blunt, and the wives of the professors did not always know what to make of her, and she did not particularly care. What she cared about was him. She ran the household, she managed the fears, she was the one who could sometimes coax him to eat, the one who understood that behind the terrifying intellect was a man who needed to be told, gently and repeatedly, that it was safe. Friends noticed that she could handle him in ways no one else could, that she could tease him out of a spiral, that she was, functionally, the regulating system for a mind that could not regulate itself. And they noticed too the loneliness underneath it, two Viennese exiles in a New Jersey town, one of them talking to Einstein about the shape of the universe, and the other keeping the whole precarious structure of his daily survival from collapsing, neither of them ever fully at home. When you read about the Princeton years, the temptation is to picture a serene golden age, the great men strolling under the trees. But it was also a holding action. It was Einstein and Adele from two completely different directions, spending years holding up a man who was always, even then, even at his most productive, in the process of coming apart. And it was for Einstein, as a gift, that Gödel did the thing that should have made him as famous in physics as he was in logic, and that instead got quietly set to the side because it said something about time that nobody wanted to hear. For Einstein's 70th birthday in 1949, Gödel gave him not a card, not a book, but a solution to the equations of general relativity. Einstein's own theory of gravity is a set of equations, and those equations have many possible solutions, each describing a possible universe, a possible shape for space and time. Godel sat down with his friend's life's work and found a new solution nobody had found before, a universe that rotates, a whole cosmos turning, and he proved that it was a perfectly valid solution to Einstein's equations, a universe those equations permit. And this rotating universe had a feature that reportedly disturbed Einstein deeply. In Gödel's rotating universe, you can travel into your own past, not metaphorically. The mathematics contains what are called closed time-like curves, paths through space and time that loop back on themselves, so that a traveller moving always forward through their own local time, never exceeding the speed of light, never doing anything the physics forbids, can nonetheless arrive back at an earlier moment of their own history. The past is not gone in such a universe. It is still there, a place, reachable, like a city you can drive back to. And Gödel's point in constructing this was not that we should build a time machine. His point was philosophical, and it was aimed straight at the intuition we all live by. The intuition that time flows, that the past is fixed and gone, that there is a real, objective universe-wide now that is sliding forward and leaving the past behind forever. Gödel argued that if a universe governed by Einstein's own equations can allow the past to be a place you can revisit, then the flow of time, the passing of the now, cannot be a fundamental feature of reality. It has to be something else, something about us, about how we experience the world, not about the world itself. Time, in the deepest sense, might not pass at all. The passage might be an artifact of being the kind of thing we are, a local illusion inside a structure that does not actually move. Now I have to be honest with you, the way this story demands, because our universe is not Gödel's rotating universe. As far as we can measure, the real cosmos is expanding, not rotating, and it does not appear to contain the closed time-like curves his solution has, so nobody is claiming you can actually go back and change last Tuesday. But that was never the point, and missing it is the same mistake as thinking incompleteness means math is broken. The point is about what Einstein's equations permit, about what is possible within the deepest theory of space and time we have, and what they permit is a universe where the passage of time is provably not fundamental. And once you have shown that the flow of time is not a necessary feature of physics, that you can write down a valid universe without it, you have opened a door that does not close just because our particular universe happens not to walk through it. The distinction between past, present, and future, Einstein himself wrote near the end of his life, is only a stubbornly persistent illusion. He wrote that in a letter of condolence about the death of a friend, trying to find comfort in the physics. Gödel had handed him the mathematics that made the illusion undeniable, and it is not clear the comfort held. So here is where we are, and I want you to feel the walls of the case closing in, because we started with a system that cannot trust its own consistency, and we have now added a universe that will not confirm that time is even real, and the same man is standing at the centre of both. The man who cannot confirm from inside his own head that his food is safe. The trap is not in one place. It is in the mathematics, it is in the physics, and it is in the mind. And it is always the same trap, the impossibility of getting outside the system to check the system, the absence of any view from nowhere, any external flaw, any final ground you can stand on and verify the rest. Gödel spent his life finding that same hole in every structure he examined, and I do not think he was projecting. I think he was seeing something real. The same real thing, over and over, in arithmetic, and in space-time, and, eventually, unbearably, in his own survival. And his mind found that hole in one more place, a place that is almost funny until you realize what it reveals about the faculty that generated all the rest. In the late 1940s, Gödel applied to become a United States citizen, and this required a hearing, and it required him to study the United States Constitution, and being Kurt Gödel, he did not skim it. He studied it the way he studied everything, looking for the reason under the reason, the axiom under the axiom, and he found something. He became convinced that he had discovered an internal inconsistency in the Constitution, a logical flaw, a loophole through which the United States could be legally, constitutionally, turned into a dictatorship, using nothing but the document's own rules turned against it. He was alarmed. He told Morgenstern. Morgenstern told Einstein, and on the day of the hearing, Einstein and Morgenstern went with him, partly as witnesses, and partly, one suspects, as chaperones, because they were worried he would derail his own citizenship by lecturing the judge on how to legally end American democracy. The story of what happened in that room is famous, and I have to flag for you exactly where the documented facts stop and the legend begins, because this audience deserves that line drawn clearly, and most retellings smudge it. What is documented, mainly through Morgenstern's own written account, is that the judge asked Godel about the government of the country he had come from, and Gödel began to explain how a constitutional republic could be turned into a dictatorship, and started to say that such a thing could happen here too, and that he could prove it. And the judge, who happened to be the same man who had administered Einstein's own citizenship oath, and who understood what was about to happen, gently and quickly steered the conversation somewhere else before Gödel could deliver the proof, and the hearing concluded, and Gödel became a citizen. That much is real. But here is the part nobody can tell you, and anybody who claims to is guessing. Morgenstern wrote his account down more than 20 years later, and he never recorded what the actual inconsistency was. What Gödel found in the Constitution, the specific flaw, the loophole, is simply not documented anywhere. It died with him. Legal scholars have argued for decades about what he might have meant, spinning theories about which article contains the crack, and they are all speculation, educated guesses hung on a hole in the record. The man who could not stop finding the inconsistency in every system found one in the founding document of his new country, and then took the nature of it to his grave. And the honest thing to say is that we do not know what he saw. We only know that he saw something, and that seeing it was, by now, simply what his mind did to any structure you put in front of it. Which brings us back to the structure he could not stop examining, and could not survive, which was his own life, his own body, his own mind, and to the decade in which the external check that had held him together for 40 years finally, and permanently, failed. I want to be very careful about how I describe what was wrong with Kurt Gödel, because the easy word is madness. And the easy story is that a great mind simply broke, the way a machine breaks, and that once it broke, nothing it did made sense anymore. That is the lazy reading, and I think it is wrong, and I think it is wrong in a way that matters for the whole point. Gödel's reasoning did not stop working. That is the thing that almost nobody who tells this story is willing to face. Right up to the end, in the domains where his fears did not reach, he was lucid, sharp, capable of following an argument with the same terrible precision he always had. The paranoia was not a hole in his logic. It was his logic, running perfectly, on a set of starting assumptions that happened to be false, with no available procedure for checking those assumptions against the world. Because the only procedure any of us has for that is trust, and trust was the exact faculty that had failed. Think about what a delusion actually is. Structurally, it is not a failure to reason. Many people with severe paranoia reason better than the rest of us, more consistently, more rigorously, because they are constantly defending a conclusion and the defense sharpens the blade. What a delusion is a system with a bad axiom and no exit. Once you accept, as a foundational premise, that they are trying to poison you, then every piece of evidence gets pulled into that frame with impeccable consistency. Adele tastes your food and is fine. Well, they know she tastes it, so they only poison your portion. The doctor says you are healthy. Well, the doctor is either incompetent or part of it. Each explanation is locally reasonable. The system is internally consistent. It simply cannot be checked from the inside, because the check itself, the act of trusting some piece of outside evidence, is the thing the system has learned to root around. And here is the part that should genuinely disturb you, because it is the part that connects the man to the mathematics with a click you can almost hear. There is no argument you can make from inside a consistent system that reaches outside it. Gödel proved that about arithmetic. Godel lived it about his own survival. You cannot reason your way out of a frame using reasoning that operates within the frame. The exit, if there is one, has to come from outside, and for a system as total as a human mind, there may not be an outside available. So watch the fears accumulate, and notice that each one is a small, locally sound inference from a premise that could not be dislodged. He believed his heart was weak, so he took medications for a heart condition he did not have, and monitored himself constantly, and wore heavy coats to protect a body he believed was failing. He believed refrigeration could release dangerous gases, so the appliances in his home became objects of suspicion. He distrusted doctors so thoroughly that when he developed a genuine, serious ulcer that bled, he delayed treatment so long that he needed transfusions to survive. And the thing that nearly killed him that time was not the ulcer, but the reasoning that told him the people trying to treat the ulcer could not be trusted. He carried a small pouch of baking soda. He wore a watch that reminded him when to take his pills. He grew more isolated as the years passed, more selective about whom he would see, more dependent on the narrow circle, on Morgenstern, on a few colleagues, and above all on Adele, who stood between him and the world and vouched, with her own body and her own vigilance, for the safety of everything that reached him. And I keep coming back to that, to Adele as the external check, because it is the exact structure the second incompleteness theorem describes, made flesh and set to walking around a house in Princeton. A system that cannot prove its own consistency needs something outside itself to certify it. Godel could not generate, from inside his own reasoning, the conclusion that his food was safe, that the world was not hostile, that he could eat and live. He had proven, in the most abstract possible terms, that no sufficiently rich system can produce that kind of self-certification, and in the most concrete possible terms, in the kitchen, 3 times a day, he could not produce it either. So he borrowed an outside. Adele was the axiom of consistency he could not prove, and therefore had to assume, and he assumed her. He trusted her when he could trust nothing else, and for 40 years that borrowed certainty held the whole structure up. It is the most human thing in the entire story, and it is also, if you look at it directly, the theorem. He needed an external consistency proof. He married one. There is a version of this man's inner life, though, that almost nobody knows about, and it is the strangest and most heartbreaking part of the whole account, because it reveals that behind the fear. In the private chambers of his thought where the poison and the plots could not reach, Kurt Gödel held one of the most serenely optimistic pictures of reality that any modern intellectual has ever committed to paper. The frightened man was, in his metaphysics, a man of almost unreasonable hope. and he never really told anyone while he was alive because he was afraid of what they would think. Start with God, because he did think about God seriously, as a mathematician thinks about a theorem. Gödel constructed a formal logical proof of the existence of God. He took an old argument, the ontological argument, which goes back to the medieval theologian Anselm and was refined by the philosopher Leibniz, whom Godel revered, the argument that God, defined as the being than which nothing greater can be conceived, must exist because existence is part of being maximally great. It is an argument most philosophers regard as a kind of clever trick, a sleight of hand with the word existence. Godel did not treat it as a trick. He rebuilt it in the rigorous language of modern modal logic, with axioms and definitions and formal steps. A proof about positive properties and necessary existence, and he worked on it for decades. In February of 1970, apparently because he feared he was going to die, he finally showed a cleaned-up version to a logician named Dana Scott, who wrote it down. And Godel told Morgenstern that he was satisfied the proof was valid, that it worked, but that he did not want to publish it. Because he was afraid people would think he actually believed in God, when what he wanted them to see was that the logic was sound. It was published only after his death. Think about the strangeness of that. A man so committed to the reality of God that he spent decades formalizing a proof of it, and so afraid of being seen believing that he hid the proof in a drawer. Because he did believe. He described himself, in a private questionnaire he filled out but never sent, as a theist, believing in a personal God, following Leibniz rather than the more impersonal God of Spinoza. His wife said that although he never went to church, he was religious, and read the Bible in bed on Sunday mornings. And when he described his own philosophy, in conversations recorded by the logician Hao Wang, who spent years talking with him near the end, he used words that are almost impossible to reconcile with the terrified figure in the overcoat. He said his worldview was rationalistic, idealistic, optimistic, and theological. He kept a private list of philosophical positions, 14 of them, and they read like the creed of a man at peace with the universe. The world is rational. Materialism is false. There is a scientific, exact philosophy of concepts and of God. Concepts have an objective existence. The world has meaning, and the meaning is good. The world has meaning, and the meaning is good. That is what Kurt Gödel believed, privately, in the years when he was becoming unable to eat, because he thought the world was trying to kill him. And it goes deeper, into the most intimate document of his inner life we have, which is a set of letters he wrote to his mother in 1961. His mother, Marianne, back in Europe, had asked him whether he believed they would see each other again after death. A mother asking her son, "Will we meet again?" And Godel, the logician, did not give her comfort in the form of vague reassurance. He gave her an argument. He wrote her a series of letters laying out his reasons for believing in an afterlife, and the reasons were not from scripture, they were from rationality itself. He argued that the world is rationally organized, that this is evident from the order and regularity we find everywhere, that it is absolutely not chaotic or arbitrary. And he argued that if the world is rationally constructed and has meaning, then there must be an afterlife, because it would make no sense. It would be a violation of the rational order to create a being with the vast unrealized potential of a human mind. A being who learns only a fraction of what it is capable of learning, and then simply extinguish it, waste it, throw it away. A rational universe does not build such a thing only to destroy it. Therefore, he told his mother, "We go on." He said he was convinced of this independently of any theology, on the grounds of reason alone. He was, in a letter to his mother, proving that they would meet again the way he might prove a lemma, and he believed it. I find that almost unbearable to sit with, and I have gone back to it many times. Here is a man who has looked harder than almost anyone at the limits of what reason can secure, who has proven with total rigour that no system can guarantee its own foundations, who lives in daily terror generated by his own inability to trust, and who nonetheless, in the room where he keeps his deepest convictions, holds that the universe is rational and ordered and meaningful and good, that death is not the end, that he will see his mother again, and that he can prove it. The optimism was not naive. He was not a man who had failed to notice how dark things could get. He was drowning in how dark things could get, and underneath the drowning, load-bearing, was a serene and total confidence that reality was, at bottom, benevolent and rational and on his side. He could not extend that confidence to his own dinner, but he extended it to the structure of existence itself. There is one more piece of his inner life I have to give you, because it completes the pattern, and it is where the optimism and the paranoia finally touch, and it is the story of Leibniz. Gödel worshipped Leibniz, the 17th century philosopher and mathematician, the man who had dreamed of a universal logical language centuries before Godel and Turing, made pieces of that dream real and impossible at once. And Godel came to believe something about Leibniz that tells you the two sides of his mind were never as separate as they look. He became convinced that there was a conspiracy stretching across centuries deliberately to suppress and destroy the writings of Leibniz. That important works had been hidden or burned or kept from publication on purpose by people who did not want the truth Leibniz had found to reach the world. He said this to colleagues. He was, by the account of the mathematician Carl Menger, completely convinced that manuscripts had been destroyed, and he gestured at powerful institutions as the culprits. And there it is, the seam where the whole thing comes together. The same mind that believed the universe was rational and ordered and good also believed that a rational order this good would naturally be under attack, that the truth was so valuable that of course there were forces working across centuries to bury it, that if something was precious, it was probably being suppressed. The optimism and the paranoia were not two different systems fighting for control of Kurt Gödel. They were one system. The world is rational, ordered, meaningful and good, and therefore they are trying to poison me. Because a world this full of truth is a world where the truth has enemies, and I am close to the truth. It is all consistent. It hangs together. It is a system with no exit, and the exit it lacks is the same exit arithmetic lacks, the same exit the mind lacks. The ability to step outside and check whether the beautiful, terrible, internally perfect structure actually matches the world. And in the middle of the 1970s, the one external check that had held the whole structure together for 40 years began to fail. Because Adele was getting old, and Adele was getting sick, and the day was coming when she would not be able to stand between Kurt Gödel and the world and taste his food and vouch, with her own body, that it was safe to eat. When that day came, the borrowed certainty would be gone, and the man would be left alone inside a consistent system that had no way, from the inside, to tell him that he was allowed to live. Before I take you into that last room, I need you to understand how far the whole actually goes, because there is a comforting story people tell themselves about incompleteness, and I want to take it away from you, because Gödel took it away from everyone who understood him, and I do not see why you should be spared. The comforting story is that yes, fine, Gödel built a weird self-referential sentence. This statement cannot be proven, a clever paradox dressed up in arithmetic. But that sentence is artificial. It is a curiosity. It does not look like real mathematics. It is not the kind of thing a working mathematician would ever actually care about. So the incompleteness is real, but it is quarantined, off in a corner, touching only the strange sentences that talk about themselves. And the ordinary business of mathematics goes on untroubled on the solid ground in the middle of the room. That is the story. It lets you keep the floor. And it is false. It is false. because in the decades after Gödel, mathematicians found natural statements, ordinary-looking mathematical questions that nobody constructed to be self-referential, questions about numbers and sequences and sets that any mathematician would recognize as real mathematics, and they proved that these statements are undecidable in the standard systems. They cannot be proven or disproven from the usual axioms. The incompleteness is not quarantined, it leaks. Godel himself, working with the mathematician Paul Cohen, who finished the job in 1963, showed that one of the most famous open problems in all of mathematics, the continuum hypothesis, a question about the sizes of infinity that had been the very first problem on Hilbert's list back in 1900, is independent of the standard axioms of set theory. You cannot prove it. You cannot disprove it. It is not that we have not been clever enough. It is that the axioms we built all of mathematics on do not decide it, and never will, and you can add an axiom that makes it true, or add an axiom that makes it false, and both give you a perfectly consistent mathematics, two different mathematical universes, and nothing inside the system can tell you which one is the real one, or whether that question even means anything. The first problem on Hilbert's list of the great challenges for the century turned out to be not hard, but undecidable, unreachable, permanently open, and the tools that proved it unreachable were Godels. And there are others, found later, statements about ordinary whole numbers, about finite sequences that always eventually terminate. True statements provable by stepping slightly outside the system, but not provable within it, sitting there in plain arithmetic like little sinkholes. The ground you thought was solid is not solid. It is riddled. Most of the time you walk across it and nothing happens, and that is why the comforting story survives, because you can do a great deal of mathematics without falling into one of the holes. But the holes are everywhere, not off in a corner, and there is no map that marks all of them, because producing that map would itself require a power the system does not have. Mathematics is not a solid continent with a few weird caves at the edge. It is a surface over an absence, and the absence goes all the way down, and Gödel is the man who took the core sample and found that there is no bottom. Now let me do the thing that I think finally closes off every escape route, the move that Gödel's successors understood, and that turns this from an interesting result into an inescapable condition. You might think, all right, the standard axioms are incomplete, so let us find better axioms, stronger axioms, the true and final foundation, and build on that instead. But you cannot, and the reason you cannot is the whole point. Any system you propose as the true foundation, as long as it is consistent and rich enough to do arithmetic and specified clearly enough that you could in principle check whether something follows its rules, falls immediately to the same theorem. It will have its own true unprovable sentence. It will be unable to prove its own consistency. There is no escaping upward into a bigger, safer system, because the bigger system has the same hole in the same place, structurally, necessarily, forever. It is not that we have not yet found the foundation that certifies itself. It is that the property of being able to certify yourself is mathematically impossible for any system worth having. Every possible foundation, every one that will ever be proposed, by any mathematician, by any civilization, by any intelligence anywhere in the universe, shares the single feature that it cannot vouch for itself from the inside. That is the consensus underneath all the disagreement. Formalists and Platonists and every school in between can argue forever about what mathematics really is. And they do, but they all live under the same ceiling, and the ceiling is that self-trust is structurally unavailable. Everyone agrees on the one thing nobody wants to say. And this is where I get angry, and I think you should too. Because this is the actual state of the foundations of mathematics, the real one, and it is not what you were told. You were told, implicitly, by the whole structure of your education, that mathematics is where certainty lives, that underneath the messy world there is a clean bedrock of proof, and that if you dig down far enough you reach something absolutely secure. That is the picture. Nobody sat you down and lied to you outright. It was done by omission, by emphasis, by what gets left out of the story. Because the truth that the bedrock proves it cannot certify itself, that certainty rests on an assumption it can never verify, that the most rigorous system human beings have ever built runs, at its foundation, on unprovable trust, is a genuinely uncomfortable thing to teach a 19-year-old, and it is a genuinely uncomfortable thing for a discipline to lead with. And so it does not get led with. It gets filed in the drawer with the greatest logician since Aristotle, admired and unread. The most important thing we have ever learned about the limits of knowledge, and it lives in a footnote, because the alternative is to admit that the floor everyone is standing on is holding itself up by faith. The people who understand this best are not hiding it exactly. They just do not put it on the recruitment posters. I told you near the beginning that the theorem and the death are the same shape, and we have now built up enough that I can say it more precisely than I could then. What Godel proved is that any system rich enough to reason about itself contains truths it cannot reach, and cannot prove its own reliability. What Godel was is a system rich enough to reason about itself, a human mind, containing truths it could not reach. The truth that his food was safe, the truth that he was allowed to live, and unable to prove its own reliability, unable to certify from inside that its own terrified conclusions were unsound. The mathematics and the man are two instances of the same theorem, and the reason this should not stay comfortably over there, in the biography of an unusual person, is that you are also a system rich enough to reason about yourself. You are also unable to step outside your own mind to verify that it is working correctly. The thing you would use to check your reasoning is your reasoning. The instrument that would confirm your sanity is the instrument in question. Most of the time this does not matter, the way most of the time you walk across the sinkholes and nothing happens. You trust yourself without proof, you assume your own consistency, you eat the food, and it is fine. But the assumption is an assumption. It was always an assumption. Godel did not have a different kind of mind than you. He had the same kind of mind, running on one changed axiom, with the exits sealed, and the horror is not that this happened to a strange man in Princeton. The horror is that the structure that let it happen to him is the structure you are made of, which is the second foreshadow paying off and the third one arriving, because everything from here is descent. And there is no more machinery to explain, only a man in a house running out of the one thing that had kept the assumption alive. Godel had a stroke or a series of health crises in the middle of the 1970s, and here I have to give you one of the places where the sources genuinely disagree, because the honest version of this story keeps its uncertainties visible. Some accounts say she was hospitalized after a stroke in late 1977. Older and more numerous accounts describe her being away for around 6 months earlier in that period, hospitalized for major surgery. What every account agrees on, and what actually matters, is this. In the last stretch of Godel's life, the woman who had spent 40 years tasting his food and standing between him and a world he could not trust, was removed from the house, into hospitals for long periods, and was no longer able to do the one thing that had kept him alive. The external check failed. The borrowed certainty was withdrawn. And the system that could not certify itself from the inside was left alone with itself. You have to understand that by this point he had almost no margin left. Even with Godel present, he had been eating less and less for years, narrowing his intake down to the few things he could bring himself to trust, monitored by a nurse in his final period who described a diet that is painful to read. In his last years he was eating, on a typical day, roughly a single egg for breakfast, a spoonful or two of tea, sometimes a little milk or orange juice, and for the midday meal a small portion of string beans, never meat. Getting him to eat a carrot was described as a real breakthrough. This is a grown man, and that is a day's food, and it was already the diet of someone whose fear had eaten most of the way through his ability to sustain a body. In March of 1976, already he had been hospitalized for malnutrition, weighing about 80 pounds. That was 2 years before the end, and he was already down to 80 pounds, and he came back from it, because Gödel was still there, still the wall, still the reason to believe the food was safe. But the wall was coming down. Morgenstern, his old friend, one of the last people he trusted, kept a record of those final months, and it is among the most harrowing documents in the history of science, because it is the account of watching one of the great minds of the century starve to death by degrees while entirely lucid, and being unable to stop it. Morgenstern was himself dying of cancer during this period, so you have two dying men, and one of them drags himself to visit the other, and what he finds is a man he described as looking like a living corpse. Godel, in these last months, told Morgenstern that he felt as if he were under some kind of spell, compelled to do the opposite of what he knew to be right, which is a description, from the inside, of exactly the trap we have been circling this whole time, the awareness that the reasoning has gone wrong somewhere combined with the total inability to reach the place where it went wrong and fix it. He knew, at some level, that he should eat. He said as much. And he could not get from the knowing to the doing, because the machinery in between, the trust, was gone. And there was no way to reason it back into existence, because reason was the thing that had failed. At one point he told Morgenstern that if Morgenstern were truly his friend, he would bring him cyanide. That is the state he was in, asking the friend who was dragging himself out of his own deathbed to visit, to instead bring poison. From a man whose entire 40-year illness had been the terror of being poisoned. The fear of being killed and the wish to be killed had collapsed into the same point. He starved through the autumn of 1977. The weight fell off a frame that had never had much to spare, and on the 29th of December, 1977, he was finally brought to Princeton Hospital. And by then he weighed about 65 pounds, 30 kilograms. I gave you that number at the very start, before you knew who he was, or what he had done, or what it meant, and I want to give it to you again now that you know all of it, because it should land differently now. 65 pounds, a mind that had reached further into the foundations of reality than almost any human being who ever lived, reduced to the weight of a small child curled up, because it could not solve, from inside itself, the problem of whether it was safe to eat. He lasted about 2 more weeks. He died on the 14th of January, 1978, in the early afternoon, in a sitting or curled position in his hospital bed. He was 71 years old. The death certificate recorded the cause, and the wording is its own small monument, clinical and precise and, once you know the story, almost unbearable in its accuracy. It stated that he died of malnutrition and inanition, brought on by a personality disturbance. Inanition is the medical word for the exhaustion of the body from lack of food, the physical emptying out of starvation. And a personality disturbance, in the language of a death certificate, is the closest the medical system can come to writing down what actually happened, which is that a man's own mind, working perfectly, had concluded that the world was too dangerous to eat from, and had held that conclusion against all evidence, against his wife, against his doctors, against his own knowledge that he should eat, all the way down to 65 pounds and then to nothing. The certificate is describing a death by reasoning, a man who thought himself out of existence, and the doctor who filled it out reached for the only phrase medicine had, personality disturbance, which does not begin to touch it because there is no clinical phrase for the actual thing, which is a system so rich it could reason about itself, trapped inside its own consistency, with the exit sealed by the very logic that made it powerful. Gödel outlived him by 3 years. She had been the external consistency proof for 4 decades. And when she could no longer be present to perform that function, the man she had been holding up came down. She donated his papers, his letters, his unpublished proofs, the whole record of that vast interior, to the Institute, and she died in 1981. And I think about her more than almost anyone else in this story, because her role in it is the most human and the most invisible. The dancer from a working-class Viennese background who understood, without any of the mathematics, the one thing the mathematics proves, which is that a mind like that cannot save itself alone, that it needs someone standing outside it to say the food is safe, and that when that someone is gone, no amount of genius inside the system can generate what only the outside could provide. Now I want to close the loop I opened at the very beginning, the promise that the theorem and the death are not 2 things but one thing, and I want to do it carefully, because it would be easy to make this too neat, and this audience can smell too neat from a mile away, and the truth does not need me to force it. I am not telling you that Gödel's incompleteness theorems caused his death, that he did a logic problem and it drove him mad, that there is some mystical curse whereby proving the limits of reason dooms you to be destroyed by them. That is a movie, and it is not what happened, and if I told you that you would be right to distrust everything else I have said. The paranoia predated the theorems, the fear of the poisoned food, the conviction of the broken heart. Those started in a child, before he had proven anything. The illness was the illness. It had its own biological and psychological reality that would have existed if he had never written a mathematical symbol in his life. What I am telling you is stranger and quieter, and I think truer, which is that the same man, with the same mind, looked at arithmetic and looked at his own survival and found, in both the identical structure, and that this is not a coincidence, because the structure is real and it is everywhere, and Godel was simply the person most exquisitely tuned to detect it. The impossibility of a system stepping outside itself to verify itself is a genuine feature of reality. It is true of arithmetic. Godel proved that. It appears to be true of any sufficiently powerful formal system, of computation, of the foundations of mathematics as a whole. And it is true, in the way that matters most, and that we can least escape, of the reasoning mind which cannot get outside itself to check whether it is working, which has to assume its own soundness because it cannot prove it, which trusts itself the way you have to trust the very floor you are standing on to look for cracks in the floor. Godel did not catch a curse from his theorem. He and his theorem were both reports on the same fact. He was the fact, walking around in an overcoat in Princeton, afraid of his dinner. There is a detail about those final years that I have been saving, because it is the one that I find hardest to live with, and it is this. He did not lose his mind in the sense people usually mean. Right through the starvation, in the parts of his thinking the fear did not touch, he was still Gödel. In the 1970s, while he was declining, he had long conversations with the logician Hao Wang, and those conversations are full of exactly the kind of deep, careful, original philosophical thinking he had always done, the reflections on the mind and the machine, on mathematical intuition, on the nature of concepts, on God. The instrument was not broken. That is what makes it a horror story rather than a tragedy of decay. A tragedy of decay is a great mind-dimming, the lights going out one by one. And it is sad, but it is comprehensible. It is the ordinary erosion that comes for everyone. This was not that. This was a great mind at nearly full power, lucid, precise, capable, watching itself starve, understanding at some level that it was starving, articulating that it felt compelled to do the opposite of what it knew was right, and being completely unable to intervene in its own destruction. The lights were on. Someone was home, and the person who was home could not get to the kitchen. I keep coming back to the child they called Theorem, Mr. Y, the little boy who could not stop asking for the reason under the reason. Because that faculty, the relentless drive to find the ground beneath the ground, is the exact same faculty that proved incompleteness, and the exact same faculty that starved him. It is one faculty. The drive to get underneath every structure and check its foundation is what let him see that arithmetic has no self-certifying flaw, and it is what would not let him accept, on ordinary human trust, that the food was safe, because ordinary human trust is precisely the refusal to keep asking why, the willingness to stop, to eat the sandwich, to assume the world is not against you and get on with living. Most of us survive because we stop asking. We accept the unprovable. We eat. Theorem never learned how to stop, and the thing that made him one of the deepest thinkers who ever lived is the thing that would not let him take the one unprovable assumption that keeps a body alive. His genius and his death were not two outputs of his mind. They were the same output, pointed at different targets. And this is the part where I have to tell you that I do not have a way to make it okay, and I am not going to pretend to. Because the framework of this whole thing is that there is no view from outside, and it would be a betrayal to suddenly produce one in the last few minutes. There is no lesson here that redeems it. There is no silver lining where the suffering was worth it, because look what he gave us. He would not have traded his life for the theorem. He wanted to live. He wrote to his mother that he believed he would see her again, that the universe was rational and good and would not waste a mind like his. And then the universe, or his mind, which from the inside he could never fully separate, wasted it anyway, at 65 pounds, in a bed, 2 weeks after they finally brought him to the hospital. The man who proved that no system can guarantee its own consistency spent his last conscious months as living proof of it, and there is no frame you can put around that which makes it resolve into something comforting. It does not resolve. That is the whole point. It was never going to resolve. He proved that too. I want to bring back the rotating universe now, the birthday gift, because it turns out to be the last key, and I did not fully understand why it belonged in this story until I had sat with the death for a long time. Remember what that solution showed. It showed that in a universe governed by Einstein's own equations, the passage of time, the flow of the now, the sense that the past is gone and the future is not yet, is not fundamental. It can be absent from a valid universe. Which means, Gödel argued, that the passage of time is not really a feature of the world, it is a feature of us, of how we are built to experience a structure that does not itself pass. In the deepest description, past and present and future are not moving. They are laid out, all at once, a fixed geometry, and the powerful, total, undeniable sense you have that this moment is happening, that time is flowing through you right now, is the illusion, the local artifact, the stubbornly persistent illusion Einstein named in that letter of condolence, trying to comfort himself about a friend's death by insisting that the death, in the deepest sense, had not taken the friend anywhere, because there is no way for time to take anyone. Do you see what that does to the death? If Godel was right about time, and he was working from Einstein's own mathematics when he said it, then the walk to the institute, the two of them talking in German in the New Jersey afternoon, is not gone. It is not in the past in the sense of having been erased. It is still there at its coordinates, as real as it ever was, because nothing is ever anywhere else, because there is no flow to carry it away. And the death is there too, at its coordinates, the 65 pounds and the curled body and the personality disturbance, permanent, laid into the structure. He does not stop having died, and he does not stop having lived. In the block, the whole braid of him is fixed and complete. The child asking why and the young man in Nigsburg the day before Hilbert's speech, and the friend on the walk and the starving man in the bed, all of it, at once, held in a geometry that does not move. He proved that no system can step outside itself. And he proved, or came as close as anyone has, that the universe does not step outside any moment either, that there is no external now from which the whole thing is being watched and advanced, that the sense of a present moment sliding forward is the one illusion none of us can shake and all of us are living inside. The man had a gift for finding the same hole in everything. The absence of an outside. In arithmetic, no view from outside the system. In the mind, no view from outside the reasoning. In time, no view from outside the moment. Everywhere he looked, all the way down, the same missing thing, the same locked door, the same impossibility of the external check. So let me tell you what I think this actually means. For you, sitting wherever you are, listening to this. And then I am going to stop. Because the one thing I refuse to do is hand you a resolution that the material does not contain. You trust your own mind. You have to. There is no alternative. Every judgment you have ever made about whether you are thinking clearly was made by the same mind whose clarity was in question. When you decide that you are being reasonable, that your fears are proportionate, that your read on a situation is accurate, that you are not the crazy one in the room, the thing rendering that verdict is the thing on trial. You are the judge and the defendant and the courtroom, and there is no higher court, and there is no moment in your entire life when you have ever once been able to step outside your own reasoning to confirm from a neutral place that it works. You have never checked your mind against anything but your mind. The instrument has only ever been calibrated against itself. And almost all the time this is completely fine, and I want to be clear about that, because the point is not that you should be terrified of your own thoughts. The point is more unsettling than that, because you cannot even be usefully terrified, since the terror would also be generated by the mind you cannot verify. Almost all the time you walk across the surface and it holds. You assume your own soundness, you trust the food, you believe your senses, you take the floor on faith and get on with the day, and it works, and you are fine, and this is not a call to start doubting everything. Because that road has its own name, and Gödel walked it, and it ends at 65 pounds. The point is not that you should distrust yourself. The point is that you cannot ground your trust in yourself. It is not available to you. The certification you would need, the proof from outside that your reasoning is reliable, is exactly the thing that Gödel showed no system rich enough to reason can ever produce about itself. You are running, right now, on an assumption you can never verify, and so is everyone you have ever met, and so was every genius in this story. And the difference between the ones we call sane and the one we call disturbed is not that the sane ones have the proof. None of them have the proof. There is no proof. It is that the sane ones happen to assume the world was safe enough to live in, and Godel, for reasons that started with a child and a medical book, and were sealed shut by a murder on a staircase, assumed it was not. And both assumptions are equally beyond checking, and only one of them lets you eat. That is the thing they did not tell you, and I do not fully think they told you on purpose, because I do not think most of the people teaching you even hold it consciously. It got smoothed away, the way uncomfortable foundations always get smoothed away, into the reassuring shape of a world where certainty is available if you just dig deep enough, where mathematics is bedrock, and the mind is a reliable instrument, and reason is the ground you can always fall back to. And the truth, the one Gödel proved about arithmetic and lived about himself and glimpsed about time, is that there is no ground you can fall back to, that every structure capable of holding you up is incapable of proving it will hold, that reason cannot underwrite reason, that the mind cannot vouch for the mind, and that the sensation of solid ground beneath your certainty is the same kind of thing as the sensation of time flowing, a stubbornly persistent illusion produced by being the kind of system that cannot see its own edges. You were told the floor was solid because the people telling you were standing on it too, and it felt solid to them, and it holds almost all the time, and mentioning that it holds itself up by assumption is not the kind of thing that makes it into the lesson. The most important fact about the foundations of human knowledge is that they cannot certify themselves, and it lives in a drawer, admired and unread, next to a man most people cannot describe. He is buried in Princeton Cemetery. Godel is beside him. The papers are in the archive, the proofs and the letters to his mother, and the formal argument for the existence of God he was too afraid to publish because he did not want to be seen believing. And the theorem is exactly as true today as it was in 1931. Checked and rechecked for nearly a century, never once cracking, quietly holding open the hole in the bottom of mathematics that will never be closed by anyone, ever, because closing it is the one thing the structure forbids. Every mathematician alive works over that hole. Every computer you own runs on a proof, Turing's proof, that there are questions no computer can answer. Every reasoning mind, including the one you are using to decide whether you believe me, operates without the certification it would need to know it is sound. This is not fringe. This is the most rigorously established set of results in the history of thought, and its content is that self-trust is structurally impossible. And you were raised inside a civilization that runs entirely on self-trust and does not mention that it cannot be justified. Kurt Gödel found the missing flaw, and it did not comfort him, and it should not comfort you, and the last thing I will say about him is the thing I find I cannot stop returning to, late, when I am supposed to be asleep. He was right about almost everything. He was right that arithmetic cannot prove its own consistency. He was right, or as close to right as anyone has gotten, that the passage of time is not fundamental. He was probably right that the mind faces a fork that gives it no comfortable branch. His reasoning, in the end, was almost never wrong. It was one of the most reliable reasoning engines our species has ever produced. And it produced true, deep, permanent results at the absolute limit of what can be known. And that same engine, running on one unverifiable assumption about whether the world was safe, an assumption it could not check because no engine can check its own, concluded that he should not eat. And he did not eat, and it killed him. The reliability was real. The results were true. And it walked him, step by valid step, into a hospital bed at the weight of a child. He knew you cannot get outside the system. He proved it. And then he could not get outside his own, and neither can you, and there is no one coming to check the work, and there never was. The universe does not step outside the moment to watch it pass. The mind does not step outside the reasoning to confirm it holds. The mathematics does not step outside the system to prove it is sound. Everywhere, all the way down, the same missing thing, the door that is not there. He starved to death in a room full of food, certain of a danger no one else could see, and unable to prove, from the only place he could ever stand, that he was wrong. Neither can you,